Hello, welcome to the channel. My name is Victor, and I'm going to be your anchor for this series. So this is the part 6 of the CompTIA Security Plus exam preparation guide. So this is the 701 exam, is the latest exam in the series, now in 2024. Okay, so of course, this series, this exam version is going to last for the next 3 years. So if you're watching this video, either this time around or the next 1 or 2 years, it's still going to be valid because most times every CompTIA certification version normally stays for the next 2 to 3 years. And of course, if you have the certification, it expires every 3 years. The previous version was 601. We had 501 backwards that way. So this is the 701 exam. So in module 6, we're going to be looking at secure cloud network architecture. Now, in the 701 exam, there have been some changes which aim to address most of the concerns in cloud infrastructure. Because normally I would tell students that the job of a security analyst is to see how we can implement the elements of information security within the different IT infrastructure, whether it is cloud, whether it is network, whether it's web, whether it's mobile, whether it's data, IoT, in all the different sectors. How do we, or all the different niches and areas in tech, how do we implement security? There's a basic foundation, if you are new to cloud computing, that has been addressed in these objectives for you to be able to differentiate the different cloud deployment model. Here we're asking ourselves, what's cloud? So cloud is typically you deploying IT from a data center or from the internet. So instead of you to have your website sitting within your premise on a network, your files, you put it on a server. And that server, you can actually access that server over the internet. That's cloud computing. Instead of you to have your Microsoft Office, Word, Excel, PowerPoint sitting on your system, you have to install the desktop client on your computer. So instead of doing that, you want to push that and have that in the cloud. So you have things like Google Drive, you have things like S3. So you have different vendors in cloud. So you have Azure, that's Microsoft, you have GCP, that's Google, you also have what's it called? You have AWS, owned by Amazon. So you have different ways you can deploy either file, either network, either computing. So you see, all of these things normally you will have locally on your system. We're saying, can you have that over the internet? Can you have that on a server that you can readily access over the internet? So in cloud deployment models, we're asking ourselves, what are different ways we can actually have that? So it can be public, that's multi-tenanted. You have a multi-tenant system where it can be, let's say, a file server, and anybody can actually subscribe and have a portion of that file server. So it can be private, where just only a company can have access to that. That's what you call private servers and the rest. It can be community, where you have a combination of private and public, or it can be hybrid. Now, in cloud deployment model, there are some considerations. So you're going to ask yourself, before I choose what type of cloud model I'm going to be using, for the foundation to be able to understand how the cloud works. So we're going to be looking at security considerations. We're going to be looking at multi-tenant architecture, single tenant architecture, and also multi-tenant architecture, then hybrid architecture and serverless architecture. In serverless architecture, the bone of contention there is that I don't want to always be concerned about the PC, the size, the RAM. I don't want to be concerned about the hard disks and the rest. I just want to be concerned about my code. I just want to be concerned about my scripts, my software, my whatever. And I want all of the server issues to be taken care of. So that is a very layman way to explain what you mean by serverless architecture. Now, you have models. So there's what we call SaaS, software as a model. Then you have platform as a service. Then you have infrastructure as a service. Software as a service, for instance, is where you're saying, I don't want to have to install the software. I don't want to have to take control of the software. I don't want to have to be in charge of the software I want to use, either for business, either for billing, either for office processes, or for HR, or for payment. I don't want to be in charge of that. I don't want to even develop the software for my office use, or for my business use, or for my personal use. Let another company deploy that software, maintain that software. So I just pay a subscription fee. So you hear things like SaaS software, SaaS applications. In SaaS applications, you're only paying a subscription, and it's very minimal. You're not concerned about the security of the software. You're not concerned about how the software is going to be there. So that subscription fee you pay either monthly or quarterly or annually takes care of all of that. And that system is multi-tenant system, because you have several companies using that software. Now you have this model very, very abundant. Examples, your office suite is a software as a service. Most of your billing and payment systems like Paystack, PayPal, you just use them to like collect payments. You have educational softwares that you use in your enterprise. All of these softwares are maintained by companies. They take care of the updates, they take care of everything. They just provide the software for you, and you use and you pay a subscription fee. They have platform as a service. So the point there is that, would there be any kind of platform like a developer is going to need, that an architect is going to need? You can have them in IDs, you can have them in softwares, but they help you to deploy your work. So you refer to that as platform as a service. Same thing with infrastructure as a service. So infrastructure is going to be things like network, it's going to be things like compute, it's going to be things like storage, all of those critical things you need to drive business processes. So when you just pay for only what you need, you refer to that as when you get in infrastructure as a service. And your level of commitment in whether you're going to be using software, platform, or infrastructure is going to differ. And we're going to see that in a separate slide. Then we also have what we call third-party vendors. So third-party vendor is trying to say, okay, I am not the one involved. I am not the one deploying. I'm not the one maintaining. I'm not the one setting up. For instance, if you are to say, okay, I want to implement payment system for my website, you know, you have to set up a team, you have to pay them, you have to have collaborations with the bank, with the payment companies, with settlement infrastructure. So there's a whole lot of ball game to play. But if you want to use a third party, if you want to use another company to do that, so that's what you refer to as a third party vendor, because you are not directly involved. So in the different models, we have what we call the responsibility matrix. So the responsibility matrix is what is going to be your responsibility for whichever type of model you choose, right? So what are you going to be involved in doing? What are you going to be what is going to be your responsibility? Whether you are choosing on-premise, whether you're using IaaS, that is infrastructure as a service, whether you are choosing PaaS, that's platform as a service, whether you are choosing SaaS, that is software as a service, whether you're choosing FaaS, that is function as a service. So you have them here: on-premise, infrastructure as a service, platform as a service, software as a service, and function as a service. For function as a service, you typically involved in creating the script and the little programs that are going to be, and they can be joined together, like create a small script that is going to like collect data from people, then you send it to another script that's going to process it, you send it to another script that is going to actually run and maybe create maybe send an email to a particular client or based on some kind of parameter. So you call that function as a service. So all that underlying function of that server, you're not concerned. So if you check this table very well, so we call this the responsibility matrix. So data classification and accountability. You see, on-premise, client and endpoint protection, identity and access management, application level controls. These are the software level now. Now you now have host controls that is on the PC, on the server. Then you now have host infrastructure, that is the computing, the RAM, the storage, all of that. Then you now have physical security in terms of access control, biometrics, CCTV cameras, dogs, fence, even power, all of those kind of stuff that are very critical to security physically. These are all the different responsibilities. When you're on premise, everything is going to be the cloud customer. So you are going to be in charge. So that's why we talk about CAPEX. In cloud computing, there's what we call CAPEX. And CAPEX is capital expenditure. So you don't want a situation whereby you're spending quite a lot. And in sometimes, and that's one of the reasons why the cloud computing game is actually growing big and wide, because people want to only pay for what they need. So that's what we call OPEX. So operational expense is going to be very minimal. So you just pay for basic things. So whereas in CAPEX, you're going to be paying for, in CAPEX, you're going to be doing a lot of capital expenditure, because take, for instance, data classification, accountability, client endpoint protection, that is at the client end of that software or that deployment. So all of this is going to be in your hands, and this is going to cost a lot. Now, in infrastructure as a service, so the cloud customer takes care of these, and part of this. And part of this, because if you're doing infrastructure as a service, you're going to configure your network, your VPCs, your access control system, your IP, your tunneling, at times your load balancing. You're going to be configuring all of those. Same thing with the host. But the physical security, you don't do that. If it's Amazon that is your provider, or Microsoft that is Azure, or GCP, Google, so they're going to be in charge of your physical security if you're doing infrastructure as a service. If it's platform as a service, take for instance, you're using something like Collab, or you're using a web-based ID platform, maybe to develop your code or to do something, you're going to see that the cloud provider is going to do a little bit more. Same thing for software as a service, same thing for fast function as a service. And so this is the CIS Control Cloud Companion Guide. So you have some ticks, some benchmarks. So the CIS is what you call the the critical security, the Center for Internet Security. So the Center for Internet Security is a body that just provides guidelines, foundations, and tells you, okay, these are some checks you need to do, these are some controls you need to implement, and all of that. So this table represents the balance between the responsibility between the customer and the cloud service provider. Now, so this is an explanation of all of the things I've talked about. The cloud security provider normally is going to be in charge of physical security, securing storage, compute, network, securing foundational elements of the network, such as distributed denial of service protection. So they're going to be in charge of cloud storage backup, security of the cloud infrastructure, make sure they isolate systems among clients, because here, multiple clients are paying for, if you have, let's say, terabyte, and you go to Google and say, okay, in Google Drive, I want to pay for on Amazon S3 service, Amazon S3 service. S3 is the cloud storage service for Amazon. So if you say you want to pay for, let's say, 500 gig, Amazon have, or Google have, thousands and thousands and thousands and thousands and thousands of terabytes, right? So you are paying for only that 500 gig. Or you go to Google or Microsoft OneDrive and say, I want to pay for 1 terabyte space to store my files. Maybe I'm a video company, or I'm a photography company, or I'm a company that consults for an architectural company, and we kind of do backups for them, their files, to be able to transfer to all of their clients across the globe. So they need a lot of storage, but we just need 500 gig. So another company is going to be using that same storage system. So is the cloud service provider's responsibility to isolate all of the tenants, all of the companies that are using it, just like in real estate, right? You have tenant 1, tenant 2, tenant 3, and they're all going to be using one facility. They're going to share plumbing, they're going to share power, they're going to share maybe waste disposal, they're going to share heat, ventilation, they're going to share AC, all of those kind of things, especially when you have a central AC system. So there is need for that isolation by the cloud service provider. Same thing with identity and access control, because you don't want a situation whereby a particular tenant is going to be having access to another tenant. So what does it look like if you get into you stay in a serviced apartment and you come into your building, and by the time you say Jack Robinson, somebody else is inside your facility or somebody else is in your kitchen. So it's absurd. So there's need for identity and access control. So you're giving a different key to access different parts of the building that you paid for. Same thing with securing, monitoring, incident response. So if something happens, if there's an incident, if there's a hack, if there's something that happens, or how do we alert system and say, okay, please, oh, something that just happened here, okay, there is a suspicious login activity to this. So how do you monitor, how do you send all of those things to whoever that's in charge or whoever paid for that particular device or infrastructure? So yeah, we also have securing and managing the data centers located in multiple geographical regions, because AWS or GCP or Azure, most of them, they have centers in different parts of the world to be able to provide latent service. In latency, we're talking about what is the speed at which items can get to the user. So we want to make sure that it's as fast as possible. So to be able to do that, so most cloud service providers are going to have data centers very close to you. So in the cloud service customers, so they do all of these things, just like what I explained in the matrix, right? So the subsequent slides are meant to explain each of these, what is the responsibility for the cloud service provider and for the tenant. So we have centralized and decentralized computing. So same concept that I just explained. So you have a situation whereby in centralized computing architecture, all the data processing and storage is performed in a single location, right?